Hello all, today in this video I am going to provide details regarding and demo video for Resnet algorithm from scratch by using an car image. So for that initially we are just importing the libraries. Here we are working with TensorFlow only, so we have imported the TensorFlow library. The TensorFlow version here we have used is 2.15, and then we are importing the libraries, other TensorFlow libraries, that is layers like input, lambda, tens, flatten, and resnet, another libraries, etc. Then we are just calling our dataset folder, that is train path and also test path. Here within this folder I am having the train image, and this folder I am having the test image. So the train folder I am calling with the train path variable, and the test folder I am calling with the test path variable, and the image size I am resizing every as 224 comma 224, since you may know that in Resnet it will accept the image size of 224 comma 224 only. Then we are calling our Resnet model by using the image size, weights, and also we are giving an function like include top, which is we have set as false. Then we are declaring the summary of the ResNet. So this will show what are the layers which is having in the ResNet model. So now then after we are going to work with the layers, that is for layer in ResNet layers, layer dot trainable is equal to path. Then we are declaring our folders. So in the train folder, what are the labels or classes having? So it's having nearly three classes, that is Audi, Lamborghini, and Mercedes. So we are calling its all the three labels in an variable called car label, and then we are setting the flatten layer by using the x variable. And also we are calling the ResNet output, that is here we have declared an output, no ResNet, that output we have calling over here, and using it we are compiling our model. And before we are just making the dense layer. In the dense layer we are making the length of the folders, that is here it will make it as 3, since we have nearly 3 classes, and the activation we have made as softmax. Then we are creating our model by using this input and outputs as prediction. Then we are again displaying the summary of our ResNet model. Then we are compiling it. For compiling, we have used the categorical cost entropy loss optimizer is or Adam, and other metrics we are using as accuracy. Then we are image data generator to rescale our image. So here you can see we have also reshaping both our train data set and also test data set, and by using this variable only we are following our next fit function. So then here we are training the make model for nearly 50 approaches. So you can notice that we are getting the value for loss, accuracy, validation loss, and validation accuracy. So you may know that for a better model we must receive a less validation loss when compared to loss, and a higher validation accuracy when compared to accuracy. But you can see that here is some it's not up to the level. Accuracy is only high when compared to validation accuracy. Loss is only less when compared to validation loss. So this model may be affected by overfitting. In order to avoid the overfitting or underfitting issues, we will make our previous some future videos, and then we are plotting our graph. You can notice that the train loss is high when compared to the validation loss, and when coming to accuracy you can notice that train accuracy is high when compared to the validation accuracy. Then we are testing our model. For testing we are making two save the model in a file, and based on that we are using the testing of the model. For testing we are using some other data which is unseen data. So we are just making the images to display, just giving an image, so which is the and just predicting whether it is an Audi or Lamborghini, etc. So here for that we are also giving an if condition, that is if A is equal to 0. For A we are predicting as NP of R max model is dot predict image data here you can find. So this image data is the pre-processing input of the X is the input image. Here you can see X is the input image dot image to array. So this is the thing. So based on this condition, if it is A is 0 means it will display Audi, if it is 1 means it will display Lamborghini, and if not means it will Mercedes. So then we are making a definition to just make everything within the definition, and then we are making at display the model. Here we are giving a input image as Lamborghini, and you can see it's displayed Lamborghini. Sometimes it may not display as it is, since our accuracy is not to the expected level. So sometimes there may be some variations within this model. So in the future video we will make some videos regarding how to solve this overfitting and underfitting issues. Thank you.